Goddard Rover Command, Mission Control, come in. This is Captain Chuck. I read you loud and clear. Thank you, Mission Control. I'm going to commence my video feed now. Let me make it bigger. Hey, good morning, Pioneers. Today's challenge is all about following directions and being precise with your movement. Mostly because on my trip back home to Earth today, I'm going to have to make sure that I'm exact. Because hitting a little tiny piece of Earth all the way from Saturn, way out there in the solar system, well, I'm on Titan around Saturn, it's essentially Saturn, that's going to be super hard. If I get my trajectory off even a little bit, I'm going to end up sailing right past Earth. So it's really important that I punch in those codes correctly as I'm setting my course, and that I'm really precise with those things. I just wanted to talk before you do your activities and your challenges today, just about what I think is interesting about space travel. I wanted to pull up a picture of the solar system real quick. Alright, so the first thing that I don't like about this picture of the solar system is that these planets are so close together. When I was with you back on Earth in the classroom on Monday, remember Alex noticed somebody had said they were curious about something about space, or why they call it space, and I remember sitting next to Alex and he noticed that space has a ton of space. So the first thing that's wrong with this picture of the solar system is that those planets are so close together. That's not space, that's all crammed together. But that's one thing that we got to do when we draw pictures of our solar system, is we either have to get a really big piece of paper or we have to draw it kind of wrong. But if these planets were all this close together, Mars, Venus, Earth, and the Moon there, I mean Mercury, sorry, come on Captain Chuck. Mercury, Venus, Earth with its moon, Mars next. Those little tiny rocks there is the asteroid belt. Then Jupiter and Saturn where I'm at, and Uranus and Neptune back there. If those were all so close together, we would see the moon. We would see the moon the same way we see Jupiter here. It would seem so close. That's just not true. It's space. There's such big distances. Next time that you have some free time in St. Louis while we're not on mission, and you go to the Science Center, you may have noticed that there's those circles on the wall between where the planetarium is and where the IMAX theater is, and there's 30 circles there because there's actually 30 Earths that fit between the Earth and the Moon, but we always draw it so close together, kind of like we have right there. So I'm not close to you right now. I'm super far away, and to get there, I'm not even going to draw a straight line for my course like that. It's not going to be like that from Saturn to Earth. It's going to be curved. I've got some objects to show you to think through this. And then I'll let you get to your challenges. Alright, so I've got an orange here. Special space orange. It's now been in space. I've got an avocado here. I guess this one is a little bigger, so we'll say that this is Earth. This one's a little bit smaller, we'll say it's Titan, because Titan's a little bit smaller than Earth. And we'll say this little tiny coffee bean. Remember my coffee that I drank yesterday on the surface of Titan. This is my spacecraft. And so I can't just go straight between Titan and the Earth, because what are they doing? They're both orbiting the sun, like we talked about on Monday. So Earth's, well, I can't think about which is the right way for you. Let's say the sun's over here. Earth is going in a circle around the sun, right? At the same time, Saturn's also, or Titan, around Saturn, is going around the sun. So they're both going around. Oh, my space lag is making this video look a little weird, I think.